Indefinite integral, integration of inverse trigonometric functions. So here we are exploring the indefinite integrals involving the inverse trigonometric functions. You know that there are 6 inverse trig functions: sine inverse, cosine inverse, tangent inverse, cotangent inverse, secant inverse, and cosecant inverse. For each of these, there are different formulas. The first one, the integration of sine inverse x is equal to x sine inverse x plus the square root of 1 minus x squared plus the constant of integration. Similarly, for the cosine, the formula looks similar. For cosine inverse, the formula looks similar. The only difference is this sign here. In the sine function, when you're integrating the inverse sine, here is plus sign. When you're integrating the inverse cosine, here is the minus sign. Similarly, let's look at tangent and cotangent. In case of tangent, integration of tangent inverse x is x tangent inverse x minus half natural log of 1 plus x squared plus c. And in case of cotangent inverse, this sign in the middle is plus. Everything else is the same. And you can also see the similarity between the secant inverse x and cosecant inverse x. Secant inverse x, integration of secant inverse x is x times secant inverse x minus the natural log of the absolute value of x plus the square root of x squared minus 1 plus the constant of integration c. Whereas in case of cosecant inverse x, this sign here, it is plus. There was minus in secant inverse and plus in cosecant inverse. So we need to remember these formulas in order to solve the problems or integrate the problems involving the inverse trigonometric functions. Example, evaluate the following integrals. So here we have 2 indefinite integrals involving the inverse trig function. Let's work on part A. In part A, we have to integrate sine inverse 3x. So in part A, we need to integrate sine inverse 3x with respect to x. Now, in order to integrate sine inverse 3x, we need to know the formula for the integration of sine inverse x. So from the previous slide, we have seen that the integration of sine inverse x with respect to x is equal to x sine inverse x, then plus the square root of 1 minus x squared plus the constant of integration. So that is for sine inverse x. But here we have sine inverse 3x. This is the composite function with the inside function as a linear function. So meaning of that is you can use the formula and then you can divide the result by the derivative of the inside function. So let's do that. If I use that formula, here we have x sine inverse x. In place of x, I have 3x sine inverse 3x, then plus the square root of 1 minus x squared. 1 minus in place of x is 3x squared. Then divide everything by the derivative of the denominator, derivative of the inside function. Derivative of the inside function is 3. Then plus c, which is equal to, so here we have 3x sine inverse 3x sine inverse 3x with the denominator of 3, then plus square root of 1 minus 3x quantity squared is 9x squared. Denominator is again 3 plus c, which can be written as here 3 and 3 gets cancelled because 3 divided by 3 is 1, so they cancel out. And we have x sine inverse 3x, then plus, here I'm dividing by 3, which is same as multiplying by 1/3. 1/3 is square root of 1 minus 9x squared plus c. So that is the value of the integral given here in part A. Now let's work on part B. In part B, we have to integrate cosine inverse 5x minus 1 with respect to x. We know the formula for integration of cosine inverse x. Integration of cosine inverse x with respect to x is x cosine inverse x minus the square root of 1 minus x squared plus c. That is the formula. So when we have x here, this is the formula. Now in our example, we have cosine inverse 5x minus 1. So here we have the linear function as the inside function in this composite function. So what we'll do is we'll use this formula and then we divide by the derivative of the inside function. We use the formula with 5x minus 1 in place of x, and then we divide by the derivative of 5x minus 1. So let's use the formula. We have x times cosine inverse x. In place of x, I have 5x minus 1. So we'll do 5x minus 1 cosine inverse 5x minus 1. And then we have a minus sign, square root of 1 minus x squared. In place of x, I have 5x minus 1, quantity squared. We have to divide all this by the derivative of inside function. Derivative of 5x minus 1 is 5. So we divide by that 5 and then plus c, which is equal to, now here, if I multiply 5x multiplied to that, it will be 5x cosine inverse 5x minus 1. And then negative 1 multiplied to that, that will be negative cosine inverse 5x minus 1. Then minus square root of 1 minus, if I FOIL this one, 5x minus 1 times 5x minus 1, it will be 25x squared minus 10x plus 1, if you FOIL that. And we are dividing all this by 5, and then we have plus c, which is equal to, over here in the first term, 5x cosine inverse 5x minus 1 divided by 5. In that case, 5 and 5 will get cancelled. We get x cosine inverse 5x minus 1. In the second term, we are dividing by 5, which can be written as 1/5 cosine inverse 5x minus 1. Then minus, here also we are dividing by 5, so it can be written as 1/5. And then in the square root, I have 1. Okay, let me simplify this properly here. If I distribute this negative sign, negative and negative, that will be positive 10x. That 10x will be positive. And then this one, if I distribute, that will be minus 25x squared. Minus 25x squared. By distributing this negative, this 1 will be negative 1, and here is positive 1. They will get cancelled. So we just have 10x minus 25x squared inside this square root. And at the end, we have plus c. Plus c. So that is the value of the integral given here in part B. Example, evaluate the following integrals. Here we have two indefinite integrals. First, we are going to work on part A. And you can see in part A, it involves the integration of tangent inverse. If you recall the formula, integration of tangent inverse x with respect to x is equal to, it is x tangent inverse x minus half natural log of 1 plus x squared plus c. That is the formula. So that is the integration of tangent inverse x. But here we have tangent inverse 2x minus 1. Here we have the composite function with inside function as a linear function. So we can apply this formula by replacing x by 2x minus 1 and later on dividing the result by the derivative of inside function. So let's see what we get by doing that. So here we have the integration of tangent inverse 2x minus 1 with respect to x In place of x, I have 2x minus 1. So if I use that formula, in place of that x, I'll write 2x minus 1, 2x minus 1, and then tangent inverse 2x minus 1 minus half times the natural log of 1 plus x squared. In place of x, I have 2x minus 1, 2x minus 1 squared. We have to divide all these by the derivative. The derivative of 2x minus 1 is 2, and then plus c. Now let's simplify again. If I multiply 2x times that, it will be 2x tangent inverse 2x minus 1. And everything has the denominator 2, so I can write denominator 2 for that. And then minus 1 times that, which will be tangent inverse 2x minus 1. Denominator is 2 again. We are dividing by 2 there, that's why. Then minus, over here, we have to be little careful when we simplify this. We have natural log of 1 plus 2x minus 1 quantity squared. That is 2x minus 1 times 2x minus 1. So if we FOIL that, we get 4x squared minus 4x plus 1 divided by, here we have a half. Half divided by 2 is 1/4, or 4 in the denominator, plus c, which is equal to, now this is our final step. Here you can see 2 and 2, they divide, and then we have 1 times x tangent inverse 2x minus 1, x tangent inverse 2x minus 1, and next one is half tangent inverse 2x minus 1, and then minus 1/4 natural log of 4x squared minus 4x, and then here we have 1 plus 1, which is 2, plus c. So that is the value of the integral given here in part A. Let's work on part B. In part B, we have to integrate cosecant inverse x minus 1 with respect to x. So we are integrating the cosecant inverse. We know the formula for the integration of cosecant inverse x with respect to x is equal to x cosecant inverse x, then plus the natural log of x plus square root of x squared minus 1 plus c. That is the formula for the integration of cosecant inverse x. Now here, in place of x, we have x minus 1. So what we are going to do is, we are going to use the formula by replacing x by x minus 1. And then later on, we divide by the derivative of this inside function, because this is the composite function, and inside function is a linear function. But here you can see the inside function is x minus 1. So the derivative is 1. So you are dividing by 1, which is same as not dividing. So if I don't show you that division, I'm still dividing by 1. That's something to consider here. Okay, so we have x, but that is x minus 1 in this case. Cosine inverse in place of x, x minus 1, then plus the natural log of absolute value of x minus 1 plus the square root of x minus 1 squared minus 1 plus c. We have to divide here by the derivative of inside function. That is, we are dividing by 1, so this will not change. It will remain just like that. If you distribute this x times cosine inverse, it will be x times, oh, hold on, I am writing cosine inverse. This is not cosine inverse. This is cosecant inverse. Look at that. Because I am using the formula for the integration of cosecant inverse. So that was the writing error. Cosecant inverse. So this is cosecant inverse. So it becomes x times cosecant inverse x minus 1. And then negative 1 multiplied to that, it will be negative cosecant inverse x minus 1. Then plus the natural log of x minus 1 plus the square root of, we are going to FOIL this, x minus 1 times x minus 1 is x squared minus 2x plus 1. And at the end, you can see there is a minus 1. This is inside the square root plus c. So the final step or final answer will be x cosecant inverse x minus 1 minus cosecant inverse x minus 1, then plus the natural log of x minus 1 plus the square root of, inside the square root, negative 1 and positive 1 will get cancelled. So we have x squared minus 2x inside the square root. And this is all inside that absolute value sign plus c. So that is the value of that integral given here in part B.